Section 1.5, more on identities. Example 1, we write each in terms of sine theta. Given the tangent theta. Tangent theta is sine theta over cosine theta as the ratio identity. So sine theta on the top, there's no change, but cosine theta on the bottom can be rewritten as 1 plus minus square root of 1 minus sine squared theta. Recall the Pythagorean identity. Cosine squared theta plus sine squared theta equals 1, or cosine squared theta equals 1 minus sine squared theta. Take the square root both sides. We have cosine theta as plus minus square root of 1 minus sine squared theta. And we place it on the bottom or at the denominator. To give us the tangent theta can be rewritten as plus minus sine theta divided by square root of 1 minus sine squared theta. Example 1b, the secant theta is 1 over cosine theta. By using the reciprocal identity. As what we got from part A, the cosine theta is the same as plus minus square root of 1 minus sine squared theta. Therefore, the secant theta is 1 over plus minus square root of 1 minus sine squared theta. The next example, we write each in terms of sine theta and cosine theta, and then simplify if possible. In part A, the secant theta times tangent theta. Secant theta is the same as the reciprocal of the cosine. The tangent theta is sine over cosine. We simplify a little bit more to get the numerator as sine theta and denominator as cosine squared theta. Part B, the tangent theta is sine theta over cosine theta. The secant theta is 1 over cosine theta. We have two fractions. The denominator is the same as cosine theta, so we rewrite them using the common denominator as cosine theta and the numerator as sine theta plus 1. Next example, sine theta times cotangent theta minus 5 cosine theta. We copy sine theta. The cotangent is cosine theta over sine theta minus 5 times cosine theta. In this case, we can see the first term as sine theta and sine theta that they can be reduced. Therefore, we have cosine theta minus 5 cosine theta. Simplify one more time. This is the same as 1 of the cosine theta minus 5 of the cosine theta, which will give us negative 4 times cosine theta. Number 3, add and subtract as is indicated. Then simplify your answer if possible. List all answers in terms of sine theta and or cosine theta. As you see in example 3a, 1 over sine theta plus 1 over cos. As you see in the example 3a, 1 over sine theta plus 1 over cosine theta. To simplify, since both of them have different denominator, we are going to find a common denominator, which is the product of sine and cosine. So we multiply the first term, both numerator and denominator, by cosine theta. And similar to the second term, we multiply the numerator by sine theta and denominator by sine theta. So now both of them have the same denominator or the common denominator. and then regroup them using the same denominator to get cosine theta plus sine theta on the top divided by sine theta times cosine theta. Example 3b, cosine theta plus 1 over sine theta. We are going to simplify this expression. As you see, cosine theta has denominator 1. So the common denominator would be sine theta. We are going to multiply cosine theta by sine theta over sine theta. And then rewrite them all together using the same denominator, which is sine theta. So the first term is a product of cosine theta and the sine theta plus 1. And this is our result. Example 4, multiply and simplify. Part A, we have the product of sine theta plus 3 times. Example 4, multiply and simplify. In part A, you have the product of sine theta plus 3 and sine theta minus 2. We treat them using the Fourier technique. The first times the first to obtain sine square theta. The outer times the outer, we have negative 2 sine theta. The inner times inner terms, we have positive 3 times sine theta. And the last times last, which is 3 times negative 2 to get negative 6. After you simplify, after you multiply them, you see the like terms, the negative 2 sine theta and positive 3 sine theta. Combine like terms to get positive sine theta. Part B, multiply 1 minus secant theta and 1 plus secant theta. The first term times first term, we get 1. The outer term times the outer term, we get positive sine of the secant theta. The inner times the inner, we get negative secant theta. The last times last, we get minus secant square theta. And combine like terms, plus secant theta minus secant theta, they cancel out. Therefore, we get 1 minus secant square theta. The next one, the quantity cosine theta minus sine theta, power 2. Next example, the power 2 of cosine theta minus sine theta. Recall the power 2 means multiply by itself twice. And then we distribute using Fourier technique again. First term times first term, we get cosine square theta. The outer times outer minus cosine theta, sine theta. Inner times inner minus sine theta times cosine theta. And the last times last, we get positive sine square theta. Recall the Pythagorean identities. Cosine square theta plus sine square theta equals 1. The cosine square theta plus sine square theta here gives you 1. And the middle two terms, they are like terms. Combine the coefficient becomes -2 cosine theta times sine theta.